Okay, this is for Astronomy 320. Astronomy 320. We're starting on Chapter 2 now. The sky above. And so basically they tell you the learning objectives of this section, define the main features of the celestial sphere. This is all about basically how we view the universe around us, going back to ancient times. And in ancient times, okay, they imagined that the Earth was at the center of the universe. Everything in the universe orbited the Earth. That was called the geocentric model of the universe. And one of the things they came up with was this thing called a celestial sphere. Okay, so there's a celestial sphere right there, and we imagine that the Earth is the center. Okay, now what they have here, this is called the ecliptic. This is the path as seen from the Earth that the sun follows. So they imagine that the Earth is stationary and that the sun is orbiting the Earth. And so basically there's the United States, so Sacramento's right about here. And then down here you have the celestial equator. That's the projection of Earth's equator out onto the celestial sphere. Okay, so the sun goes from below to above the celestial equator. So right now the sun's up here. We're getting close to summer solstice, where for us in the northern hemisphere, the sun is the highest in the sky. So the Earth rotates and we'll be over here. And they're talking about, oh no, a day coming up it's going to be like 100 degrees outside, Fahrenheit. So anyway, in the winter solstice is down here. So right here, that's first day of spring, that's when the sun passes from below to above the celestial equator. And then over here we have the autumnal equinox behind the Earth over here. That's when we go from summer to fall. And then we go to winter here. So you got winter, spring, then we go summer, all the way to autumn, fall, then back to winter. Okay, this is around January, December. It's late December here, and obviously it's late June over here. We're getting close to that date right there. Okay, so imagine Earth at the center of a large beach ball. On the inside surface of the beach ball we see stars, the North and South Pole. So there's the North Pole up here. Okay, so there's the North Pole of the Earth, there's the North Pole. There's a star there called Polaris that happens to be really, really close to the North Pole. And then we got the South Pole down here. Okay, so next. Where is it? Okay, the next slide. This is another picture of the celestial sphere. Actually, it's the same one. What the hell happened? Hold on a second. Okay, here's another picture of the celestial sphere. This is the one that if you were taking the lab at Sac City, we'd pull this out. We actually have two of these, and the students could look at them, get their hands on them, all sorts of good stuff that we can't do. That's the sun right there. So you turn this thing up here, and you can see the sun go like this. Okay, if that's what it's doing. Okay, so you actually can turn it and see the sun go below the celestial equator, then above the celestial equator, and giving us summer, winter, spring, fall. And the reason the sun does that isn't because you know the Earth is actually the one that's moving, not the sun is at the middle of our solar system. The Earth is orbiting that, but the Earth is at a tilt of about 23.5 degrees. So that's why that happens with the sun. So the sphere around us, if we imagine Earth being stationary at the center of the universe, rotates 360 degrees in 24 hours while the Earth stays stationary. That's what we're looking at. Celestial equator is a projection of the Earth's equator onto the sky. The ecliptic is the path that the sun follows in the sky of the Earth. Okay, so there's the sun, and here would be late June, what we're coming up to. See, we're kind of more of the northern hemisphere is facing the sun. That's why our days are longer. It's warmer. Okay, then we go to a point pretty soon, or 3 months from now, where day and night will be pretty much equal to each other. And then we go into winter. Okay, that's when the southern hemisphere gets more sun, the northern hemisphere gets less sun. So it's summer in the southern hemisphere. Australia, Chile, Argentina, they got summer when we got winter. Right now they got winter while we got summer. Okay, then the spring's kind of like the same as autumn. Okay, hold on a second. Okay, we're looking at Polaris in Stellarium. Okay, that's Polaris right there. Polaris, got all this information about it. Now, what happens here as we go through time, Polaris stays in the same place in the sky. It is right up, it's like if we had an axis, if we actually had a physical axis running through the Earth and then extending out into space, it could go right through Polaris. So you see all the other stars rotate, spin, but Polaris stays right there. It's right on the axis. Okay, so then your book, you can imagine doing time-elapse photography. Your book has a picture showing what that looks like. There it is right there. There's Polaris, then there's all those stars going around and around and around. So right there, Polaris is sitting right on, if we had an axis that extended out of the North Pole, the North Geological Pole, up into space, it would run really close to Polaris. I don't think it would actually hit it, but it's so close, it's basically the North Star. Okay, so there's the North Star Polaris. So we went ahead and did our Stellarium and Polaris, watching the sky rotate around Polaris, the North Star. Now, some stars we can see them some of the times, and other times we can't see them. Polaris is up here. There's the Earth. This would be the North Pole. I had to make this myself. I couldn't find a picture I liked. So Polaris is up here. We're spinning. These stars we can see year round. Okay. When it comes night, we see these stars. The Big Dipper's up there. Ursa Major, the Big Dipper. Big Dipper is part of Ursa Major, the Big Bear. Now, these are stars we can't see all year round. We can see them sometimes, okay? But the sun gets in the way. And then these are also stars we can see part of the year, but not all year round. Even though we're spinning on our axis, part of the year the sun's over here. Remember, we're orbiting around the sun. The large melogenetic cloud is down here. Okay, we never see that. These are stars we can never see. They can see them in Chile. They can see them in Brazil. They can see them in New Zealand and Australia, places like that. We can't see these stars down here. Okay. And in 1987, they actually had a supernova explode in this large Magellantic cloud, and we couldn't see it. But so we were glad we had observatories down here in this part of the Earth that could see it, because it was like the first supernova that was observable from Earth easily. Okay, since the Kepler one from the over 500 years ago. We're supposed to have one every 100 years. We are long overdue. Now this one could only be seen. I hope they don't count this one. But then we're overdue. We should have a whole bunch of them. We should have one every 100 years, supposedly. That's theoretically what it is. We haven't had one in a long time. If we had one in our lifetimes, that would be huge, huge. Biggest news imaginable. Okay, so celestial objects high above the horizon can be seen year-round. So we're in Sacramento. Okay, there's Sacramento's right about there. Sacramento goes around like this and then around like that. Okay, low objects near the horizon can only be seen part of the year. That's these guys. These guys. Objects always below the horizon can never be seen. We can't see anything. Oh, oops, that's not what I meant to do. Hold on, I don't know. Okay, so again, like I was saying, we can't see these stars down here. Let's go to the next slide. We're going to use Stellarium to see why we can only see certain objects during part of the year. That's Orion right there. Okay, we can only see Orion in the winter. There's Betelgeuse. There's Rigel. So why is that? Let me set up Stellarium and show you. Okay, we're pointed at Orion. It's today. It's the 15th of June 2020, and it is basically 9:32, which means it's 7:32. Let's see, 9:32 corresponds to. Well, anyway, it's what time is it? I've lost this down here. So anyway, I believe it is 7:30, 6:30. See, okay, if it's 20, that'd be 8, so it's 7:30. Okay, so Orion's over here. So let's speed up and see when Orion comes up. Okay. Hold on. Okay, so I centered on Rigel. Rigel is one of the stars that are in Orion. It's called Beta Orion. Betelgeuse is Alpha Orion because it's the brighter one of the two, I believe. So let's just see what happens here. Now, when I do this, you'll see that when the sun rises, we can see, there's Rigel right there. We can see it, right? But see, here's the sun. What I have is I have the atmosphere turned off. Let me turn the atmosphere on. There's Rigel. Watch this. Turn the atmosphere on. There's Rigel right there, and I turn the atmosphere. We can't see it. It's right there. So now the atmosphere is back on. So it's over near the sun. So we cannot see Rigel this time of the year. See, we're still in June. We're up to June 19th. Okay, so let's kind of speed it up. So now we're in July. Now we're in August. Slow it down. Okay, we still, here we can see them early in the morning. We can start to see them early in the morning. Okay, not at night, but there they are, early in the morning. You got to get up very, very early to see them, right before the sun rises. When we get into September, okay, so let's go forward. So now we are in, we're still in September, oops. So you're not going to be able to see them at night, you're only going to see them in the morning. So here we are on morning, get up really, really early, there you can see it. Let's see what time that is, we can see it. There's Rigel. So we're looking at 1 a.m., 1:30 a.m. in the morning. Get up at 1:30 a.m., you can see Rigel. But then by, sun's starting to come up now. Yeah, see, it just disappeared. So by 6, a little over before 7, you can't see Rigel anymore. Okay, so that's in, it's still in September. We go further. Okay, we're up to October. You can see Rigel in the morning. Actually, we can see there, it went away. So this is daylight. Here's the morning. I mean, here's nighttime. There's Rigel right there. We can see Rigel until early the next morning. So we can see Rigel at night now. So we're up to October. So that's when you can see Rigel, Betelgeuse, and all that at night in the winter. Okay, so that's the reason why we can see some objects part of the year, not other parts of the year. So now let me figure out how to get out of this. Okay, so what I was just talking about here is where is it? Okay, stellarium, can't see the large melanoganic clouds. So up here, that's where they are. They're down here. Okay, we can't see them from where we are, but anyway, what I want to show you first, these are out of order, but okay, so here's the reason why we can only see some objects part of the year. See, when the Earth is such in our orbit, see, we're going to go around the sun like this, right? We're going around the sun like this. So when we're on this side of the sun, okay, these guys we can see at night. We're turned away from the sun. We're right here. We can see those guys. But when we look the other way, the sun's in the way. That's why we can see Rigel some of the time and not the other time. So the summer, Rigel's over here. Betelgeuse is over here. 6 months later, we've gone around the sun. We're on this side of the sun. Now we're over here. So now we can see those stars. Okay, we can't see these guys, the ones we can see in the summer. These are the ones that are here. Okay, these are the ones that are here. Okay, so stellarium, we did that. And then stellarium, okay, so let me set up this. Okay, I've got it pointed at the large Magellantic cloud. If I take away the Earth, there it is. I could take away the atmosphere too, I guess. Okay, so this is where a supernova occurred. It's a small galaxy. Okay, it's like a neighbor galaxy or a companion galaxy to the Milky Way. It's way smaller than the Milky Way, but it's its own little galaxy right there. And in here someplace, one of these guys here, but I couldn't figure it out, earlier today which was which. But one of these guys that you see here is where that supernova explosion took place. So I'm trying to figure out which one it would be today that I gave up after a little bit. So there it is. So we back out. When do we get to see it? Okay, let me turn the Earth back on. Can't see it. Let's back off on the Earth a little bit more. So it's right in here. So when do we get to see it? From Sacramento. See, we're in Sacramento. Oh, I'm in Nevada City again. Oops. Well, that's close enough. Okay, so here we go. You never see it. It's always there. Earth is always in the way when we're in Nevada City or Sacramento. Okay. The Earth is in the way. So we will never be able to see that. We have to go down to the southern hemisphere in order to see the large melanogenetic clouds. But of course in stellarium we can take away the Earth, and there it is. Okay, so going back to this slide here. There it is down there. We're up here. Earth is in the way. Earth is in the way. The whole year we can never see it. Okay, so that takes care of that one, and then we talked about this slide. Okay, sunrise and sunset. The sun rises in the east and sets in the west. The path the sun follows across the sky is called the ecliptic. Okay, that's when we way back when we were looking at the celestial spheres. I'm getting tired. The sun's position in the sky gradually changes, moving about 1 degree to the east each day. Ancient civilizations used this fact to make physical calendars to determine what part of the year it was. So Stonehenge, by the ancient Druids, they did that. Druids. This is like summer solstice at Stonehenge. I was trying to read up. I think the sun comes up between those two pillars when you're standing right here. That means that's the summer solstice. That's the longest day of the year. They specially built this because the sun's going to rise at different places during the course of the year. Okay, it moves like that. And we can see that in a little bit in stellarium. So it's going to move a little bit. And so basically it's like an ancient calendar. So some civilizations, some ancient civilizations used it to know when the good time was to start planting, because that's what they didn't want to starve to death. So that if this was like a huge thing, if they could say, okay, wait a second, when the sun is right at this position, it's this time of year, this is when we got to put our potatoes in, or whatever they were growing for themselves. Okay, so motion of the sun and stellarium. Let me set it up before I don't. Okay, there is the sun right there. It is 7:47. This is real time. It should be about 7:47. Let's see. What is that? I'll just do this. Okay. Oh, the sun's actually down a little bit. All right. So the sun's actually. Did it go over here? I'm not focused on it yet. You know what? Sun's over here. Okay. So I'm now on the sun. It's just going down. And so we're in the evening, we're at dusk, and so let's watch what the sun does. We're watching the sunset. The same thing would happen with the sun rising too. Okay, so sunset. Now here goes the next morning. Okay, sun came up here, and the sun's going to go down. Look at what right through that tree right there. All right, we need to speed this up though because it's going to take it a while. Okay. Sun rises. What tree would it go down through? It went down through that tree right there. It still kind of goes down that tree, so we got to go quite a ways more. We're actually we're up in the year 2021. So there was the tree. Now look, the sun's set way over here, but I went too far ahead in time anyway. Let's just do this. Okay. So this is today. The sun set right through that tree. So I'm going to watch this. Let's get it to maybe 4 months from now. 7, 8, 9, 10. That's October. So there was that tree it set at. See, it set through that tree, but now it's setting over here. So it moved over, and it set at a different place. So it would only set at that place on October 8th, okay? So it's pretty much a yearly thing. So we can see it actually moved during that time. We first turned it on for today, it was setting behind this tree, and now it's setting way before that. I mean, it's way to the east of that tree. Go up far enough we can see. See, there's, I went too far out probably. Okay, so let me get back to normal. Okay, it turns out this is the last slide. By the time you read this, hopefully I'll have this up. I only have, okay, I'm just going to put this up. I'm not going to put a due date on it yet. This is a work in progress. Okay, so actually let me work on this some more. I'm not going to put it up tonight. I'll put the, it's just going to say what defines an Earth day, what defines an Earth year, why can we see Polaris in Sacramento all year round, why can we only see the constellation Orion part of the year, which season is it that we can see, well, you know, mostly we saw it during the winter. Okay, this is a work in progress, so I'm going to not post this yet. I'm not going to upload this yet. Alright, so we've got, I'll go ahead and put what I have. Now, again, this is a work in progress, okay? So don't you know, if you go ahead and download this, but remember, it'll be, I'm going to add to this. This is chapter 2. I got chapter 2 there. And also, I got your quiz done. I'm going to set it up for you guys to be able to take your quiz tomorrow. And so, but by the time, yeah, this is going to take all night to upload. So, okay, let me call it quits right now, and I'll send you an email explaining everything.